Hey guys, it's Wade here. I wanted to do a quick video talking about my fuel caps and how I'm going to ensure that they stay attached to the aircraft in case I ever forget to actually latch them. You can see I don't remember exactly what model it is. I bought these off of a guy off of eBay quite a long time ago. I think about 2012, something like that. These are the Newtons, which Mike Melville described that he had in the Canard Pusher newsletter. Now the ones he had were slightly different than this, and there's a few different types. There's some types that actually have the along this ring they'll have points for 6 screws to hold it onto the aircraft. Some don't really have this ring right here. They have a little bit of a raised lip, and then this is depressed from that raised lip out. Those are usually the type that people use on Canard aircraft or any composite aircraft, because you can run your micro up to that lip and then all you see is just cap itself with maybe just a little bit of an edge, just a hair. I like these, and they were a good price. They were new. He had never used them. They do have some minor scratches on them, but I think they're probably going to get minor scratches over time anyway. So as I'm getting ready to do the strake, the whole top of the aircraft with micro, I have been kind of doing a sideline task of figuring out how I'm going to attach basically a triangular stop that, again, if I forget to latch the fuel cap, then this catches on this ring and doesn't let the fuel cap fly into the prop, which we know has happened on a number of, especially very easies, because where the fuel cap was located on the strake of a very easy was inside the prop diameter. This is just outside of the prop diameter, but even that, Long-EZs, if they are not attached, they can come off and go right into the prop. So I attached this. I'll discuss this in just a second. This is kind of a little bit tight, so to save my fingernail, I'm using this stick until it works in. So as you can see, now let me pull this through. As you can see, this is meant, that triangular piece is meant to stop the cap from flying out. And to get this distance here, I wanted to find out where my actual refueling point is and where this will be mounted into the strake, so I could kind of get an idea when I go to refuel how much lead I wanted. One issue I found, which led me to put on this is 4 inches of 1/8 inch nylon flow, that once this is cut to length, that was to protect this edge right here from getting all chewed up from the cable or from the swage lock right here. Now the problem is with the standard emergency stop, or whatever you want to call this thing, the problem with that is with the way that, at least the way I made mine up, you can see it sticks up and out, and so then if I were to put pressure on it, over time I would start gouging the edge of this nice looking edge fascia of the cap with the swage lock. So I was like, okay, I need to redesign that. So I did a quick check with just some cardboard and realized that if I could stop this from coming through the top and then actually keep it below the surface, then this will stay down here, and then only the nylon flow will be hitting that edge. So even though I obviously machined those, I went ahead and redesigned this. So I threw this up in CAD, just checked it out on the bottom here after I 3D printed it, just to check, and so that kind of stays below the surface. And then I definitely wanted to make sure that this, even if it gets pulled over to the side, because even though this is pretty much in the middle, if it's pulled straight out, but it can still go over to the side if enough pressure is put on it. So I wanted this to be down below here pretty much. So I redesigned it. Now I haven't machined it yet. I'm going to check this out. So that's what this is. I had planned on doing this video and showing you this completely finished and this crimped and cut and everything. But I'm just going to go ahead and get this video out. Right now, this is the design that it's probably going to look like. I curved it just a little bit just to make sure that I had enough room with the cable on there to get this into the tank once this is actually installed onto the top of the straight. Now I want to talk a little bit right now about this cable. I did this slightly differently than most people do. This is actually a saddle control cable, and what this is it's from a mistake. I was supposed to order 15 feet of this. I don't remember where I was or at what point in the build it was, but apparently it was probably late at night, and whatever my lame excuse, instead of 15 feet for this 1/16 inch control cable, I ended up ordering 15 inches. So this is the entire length of this control cable that was custom made by Aircraft Spruce with the saddle on here. I think it's called a saddle, whatever, or a fork. Maybe it's a fork, I guess. But whatever it is, it's two-pronged. And I decided, after looking on the Newton website, and Newton is based near London, England, that I wanted to get something. Now Newton's is slightly different. This is an electrical connector, and you can kind of use these. I've seen people, you can crimp this on and then bend that over, and that will get you enough to get you in and secure it with that stainless steel nut. So I was looking at ordering those from Newton, and they're a little bit different than this, but they're basically this type of setup here. And I think with there you run the cable through and then around, and then it secures it with kind of a double loop back, or a single loop back, but a loop back. Anyway, so that connects here, and they're only $3 for a set of them, but they're like $26 for shipping, so it'd be $30 just for these two little tabs. And I'm like, okay. Their cable is essentially this 1/16 inch stainless steel cable. Now the one thing about their cable is it is covered with plastic, which I thought about with the Nylaflow, so it wouldn't dig in here. Of course, again, I put the Nylaflow on there to help protect the edge of this. Now on here, what I have is, I tried this by hand, just out of some scrap 36,000 3/16 inch stainless steel. When I drilled it, I was trying to keep this edge narrow, so when I bent it, it went into that depression on the bottom here. But when I bent that, and I had this narrow tab and I tried to drill it, it got a little bit too close to the edge. So I just said, you know what, I'm not messing around with it. What I need to do is drill the holes first and then cut it out, which meant, of course, machining it. So I drew this up in CAD. Somewhere around here I have the little 3D printed model that I made, that I started in CAD, and then so then I did exactly that. It's kind of hard to see it in there, but there's basically the machined version of this. Same stuff, 36,000 3/16 inch stainless steel, and then I just have a clevis through there, a couple of thin washers. I doubt if it's maybe an ounce heavier. Now the one reason why I did it, I don't really have a grounding clamp. The only thing I have is this welding clamp. But one thing I wanted to do was I wanted a little bit of this protrusion right here on this, enough obviously to drill the hole and have the clevis and have this custom terminated fork on this 1/16 inch cable. But with this fork, with the flange on the fork and then this little bit of a protrusion sticking out, what that does is anytime I go to clamp on to this when I'm refueling, it gives me a solid couple of inches here to clamp onto, instead of obviously this cable is covered anyway, which I want it protected, so this will always be the area where I clamp on. Now this hole here on the bottom, which I'll have even in this other mod, I just did some lightning holes here. And there's a good ½ inch of 2024 aluminum around the lightning hole, so I'm sure that they're not going to weaken this. But the reason again why there's that hole on the bottom is inside this tank. You might even hear it a little bit. You can kind of hear it rattling. Inside the tank, as soon as I open up this hole, there should be a coil of copper wire, and that wire zigzags through 2 or 3 different points, especially up front, and it zigzags up and down, so it'll break through the surface of the fuel in any position of the aircraft, whether it's nose down or whether, you know, I'm filling it to the tabs with the nose up. But those wires connect to the block that the fuel check valve on the bottom of the front of the strake is threaded into. So I could actually put the grounding clamp on the drain valve when you go to check for water. So I can either clamp onto that or I can clamp onto here. I think with this, without me going to do any damage to the cable over time, because it's always going to be on this area right here, probably just clamp onto this. It's probably easier. I'm going to have a rubber pad that I'll set down here so that when I put this down and put it on the strake, I noticed on my buddy Guy Williams, he's got an older, beautiful Long-EZ, 1982, when it was finished, and it's a very nice Long-EZ. But he has chips that I actually helped him fill in with paint. He had probably about 5 different chips out in here where you could tell that it was just from this hitting the paint surface a little bit too hard. So I'm going to machine these. I'm not going to do them right now. That's why I'm going to go ahead and close out this video. I'm going to do them in between when I have micro on the strakes or on the wings or what have you, and you know, I'm waiting that 4 or 5 hours for it to green up before I do some cheese grating on it. And anyway, in between the microing of the top of the aircraft, I'll get these things machined out. And of course this is a little bit down the road, but I kind of like to work on these things because I can, you know, look at this design and do 5 to 10 minutes on CAD and then hit the print button and it 3D prints it out. It may take 20-25 minutes to 3D print, and in the meantime I could finish up whatever I'm doing and just go to sleep, and then the next morning I pull it off and come in the shop and check it out, make my notes, and then kind of like this one. You know, this probably went through 4 or 5 iterations where I would just print it out. These are only about 20 thousandths inch thick, so they don't use up hardly any plastic. I just check them and then I just keep pressing on from there. So that's why I'm kind of designing this over time, and I would do maybe half an hour, a little bit each day. I didn't even really report it on my blog for quite a bit, and that's kind of how I do on a lot of things. I don't really report that much on the blog just because I'm just doing maybe a half an hour on something, and then I move on and I just, you know, fit it in between my major tasks. So that's it. Wanted to show you that, and that's how, you know, it's going to be about this long. I don't know if you can see it on the camera. I can't see oh, that's another reason why I wanted to do this. In reviewing different cameras, I kind of found a cheaper brand. It's called an Akaso, but I found kind of a deal on eBay, so I pulled the trigger and was just curious to see how this thing works. So this is what I'm filming this on. This is Akaso. I believe it's filming because the blue light is blinking. So this is about the length right here that this will stick out when I'm refueling, and that'll put this chain on the bottom. But to be clear, if I wasn't clear, that copper wire will go into this bottom hole. I don't know if I explicitly pointed that out, but so the copper wire will connect to this bottom hole. Not really for strength, you know, it's not to secure it if this thing comes undone. That's just this coming up on the bottom of this inside the tank. But it's for the electrical ground connectivity, or earth as some of you people say, and you know who I'm talking about. But yeah, so it's going to be right about there, and that's it. Again, it will look like that. Once I get done, I'll test that out. Alright, hey, thanks for watching. Cheers.